We will continue our lecture 5th from this example 9.2. Write an equilibrium constant expression for the reaction of nitrogen and hydrogen to form ammonia at 150 to 200 atmospheric pressure and 450 to 500 degrees Celsius while iron is used as a catalyst. This is related to our topic which we have discussed, derivation of the expression for equilibrium constant of general reaction. Okay, what we will have to do in this example, we will have to write the equilibrium constant for this general reaction. Look at this reaction. Here two reactants are reacting and a product are formed. So here 1 mole of nitrogen gas is reacting with 3 moles of hydrogen gas and will give us 2 moles of ammonia gas. Okay, so how we will write the equilibrium constant for this reaction? We will have to write the equilibrium constant by writing the product concentration to and the coefficient is 2. This coefficient shows the molar concentration, moles, how many moles of ammonia gas are formed. 2. The nitrogen concentration of nitrogen to the concentration of hydrogen gas, and how many moles of hydrogen gas? 3 moles. So 3 is the coefficient of hydrogen gas. So this is the equilibrium constant for this general reaction. Okay, now look at this practice problem. This is somewhat for you student, but let us look at these problems. I will have to do this for you people. Okay, write an equilibrium constant expression for the following reversible reaction. First one is nitrogen gas is reacting with oxygen and will give us the nitrogen dioxide. Okay, so how we will write the equilibrium constant for this reaction? Look at this equation. We will have to write the product concentration and their coefficient. Coefficient means 2 moles of nitrogen dioxide are formed. Here is 1 mole of nitrogen and 2 moles of oxygen are reacting together and will give us 2 moles of nitrogen dioxide. So nitrogen dioxide concentration, and will put the coefficient, or we can see the moles of nitrogen dioxide to the nitrogen concentration and oxygen gas concentration, and the coefficient is 2 because here 2 moles of oxygen are reacting. The second one is nitrogen and oxygen are reacting and will give us nitrogen peroxide. So what we will have to do for writing this equilibrium constant, we will put this nitrogen peroxide and the coefficient is 2 because 2 moles of N2O are formed and 2 moles of nitrogen gas. So nitrogen concentration of nitrogen to the coefficient of this gas or this nitrogen concentration, 2 moles of nitrogen are reacting, so the coefficient is 2, and 1 mole of oxygen, so oxygen gas concentration. Okay, now the third one is sulfur dioxide is reacting with 1 mole of oxygen and will give us 2 moles of sulfur trioxide gas. So the equilibrium constant will be like this: sulfur trioxide and 2 moles, so the coefficient will be 2, and sulfur dioxide and the coefficient will be 2 because 2 moles of sulfur dioxide are reacting with 1 mole of oxygen. Okay, the last one is phosphorus trichloride will react with the chlorine gas and will give us phosphorus pentachloride, which is PCl5, and the equilibrium constant for this reaction will be PCl5, and there is no coefficient because here is only 1 mole of product are formed, and the concentration of reactants will also be of 1 mole. 1 mole of phosphorus trichloride will react with 1 mole of chlorine gas, so here will be no coefficient. Concentration of PCl3 and concentration of chlorine gas. Okay, this was all about the derivation of expression of equilibrium constant for general reaction, and this was all about the practice problems, or we can say the examples of this topic. So I hope you will understand this